From the moment a baby is born, that child needs food, clothing, and energy for a lifetime. All those things must be produced while saving land, water, and biodiversity. It is about doing more with less. Already, in the time you've been watching, another 200 babies have been born with the same needs. How do we meet those needs for a growing planet? One step is through the development of new plant varieties. Research is the key. Whether conventional or engineered, innovation begins with assessing needs. Scientists and breeders must understand the needs of farmers, processors, and the planet. Plant breeding has been making plants stronger for 12,000 years, including creating higher yields, improved pest and disease resistance, earlier maturity, and better quality. There are all sorts of needs plant breeding must address, including the 124 million people in 118 countries who are deficient in vitamin A and need crops with higher carotenoids, or the 106 million people affected by floods in an average year, or 900 million hectares of soil affected by salinity that require crops which can grow in those conditions. So plant breeders begin screening, looking for crop traits from existing varieties and related plants for such things as drought tolerance, disease resistance, or other traits. Hundreds of genetic resources, plant populations, wild relatives, and existing varieties must be screened to see if they have the unique quality that will help improve a crop by breeding a new variety. The genes for specific traits are often not visible or predictable on plants. For example, a tiny tomato can transfer a gene for large fruit size, or a green tomato can carry a gene for dark red color. Having identified those needed traits, plant breeders make a new variety by combining the traits with the best existing varieties. Breeders call this crossing, and it creates new varieties that better fit our human needs. That means selecting plants to have all the desirable characteristics farmers and consumers need. They must be high-yielding, easy to harvest, resist pests and diseases, and have other needed qualities like good taste, the right size, and excellent nutrition. This job can be complicated and global in scope. For example, 68 varieties and land races, coming from 18 countries, can be found in just one pedigree segment of the Sonalika wheat variety. It takes extensive work and experimentation, involving hundreds of crosses, to increase the diversity of modern crops. When the right cross is selected, it needs to be grown and regrown to make sure it reproduces with the same traits time after time. Stabilizing the performance of a new variety means that it performs in the field. For example, stem rust has been under control for over 30 years due to the widespread planting of wheat varieties with resistance. Now a new rust strain, called UG99, is spreading in Africa, Asia, and the Middle East. In Kenya alone, it caused losses of up to a third of the wheat crop in 2007. So making sure new varieties can resist it in the field is essential, and can hopefully achieve decades of control to this new disease. That means testing, and lots of it. The next phase of work grows the variety in various field conditions over several years and multiple environments to test how it performs on the farm. The investment that has gone into a future variety until this point in time can be $1 to $2 million US. Only then does it move to producing. The seed sector produces the seed by growing it in fields or greenhouses under strict standards. Facing the challenges of weather, soil conditions, and all the other risks that farmers face, extra care is taken to ensure the variety remains true to its type and will be of good quality for farmers to plant. Through plant breeding, annual yield increases of 1 to 2% are achieved in many crops. Those gains allow global food production to rise 25% between 1990 and 2000. But it is not easy. Plant breeding requires large investments in people and money. Plant breeding companies, on average, reinvest 12 to 15% of their sales on research and development. This equates to over $4 billion US per year in R&D. It also takes time, up to a decade for a variety to be developed. During those years, a baby born today will share the planet with 1.5 billion more people. Feeding them demands research and development, because seed is life.